Hello people, welcome to the video series where we learn Kotlin by solving HackerRank algorithms challenges. In the last video we went through a very big sum and now it's time to see what is this diagonal difference is all about. A disclaimer here, although HackerRank says this is an easy problem, this is a bit harder than other easy problems. So if you have hard time understanding it, it's totally okay because now we're starting to think algorithmically. Okay, let's read the problem description. Given a square matrix, calculate the absolute difference between the sums of its diagonals. For example, the square matrix ARR is shown below. 1, 2, 3, 4, 5, 6, 9, 8, 9. Okay. I don't know why it's 9, 8, 9. It should be 7, 8, 9. But okay, it doesn't matter. So the left to right diagonal, which is 1, 5, and 9, sums into 15. And the right to left diagonal is 3 plus 5 plus 9, which is 17. And the difference between two is 2. Okay, their absolute difference is 2. So that is how you will calculate for other matrices as well. First, you need to find the left to right diagonal or the primary diagonal or the first diagonal, and then you will need to calculate the secondary or right to left diagonal, and then find the difference between these two. This is cool. We can see another example. For example, this one. The first diagonal is 11, 5, and minus 12, which is 4 in total. And we also have 4, 5, and 10, which is 19. So the difference is 15. Okay? And it also, like HackerRank also explained this. This is the primary diagonal and this is the secondary diagonal. And the difference, absolute difference between these two is 15. And if you don't remember what an absolute value is, it is, you can follow this link here. It is like if it's negative, converted to its positive complementary. And that's it, like no negatives, okay? And yeah, this is what an absolute value is. Cool. Let's also see what we have here. We have a function diagonal difference, which is given an array, but this array is weird. See, it's not an array of integer, but it is an array of integer. So it's two-dimensional. What does this mean? Before starting, let's try to understand two-dimensional arrays, okay? For that, I will jump to IntelliJ IDEA. Let's say we have an array, which is an array of 1, 2, and 3. Okay? So, can you guess the type of A? The type of A is array of integers, right? Because each of its elements is integers. Let's say we have another one, which is B, and which is also an array of integer, and it, let's say, holds values 4, 5, and 6. Okay? And lastly, we have C, which is holding different values 7, 8, and 9. Okay? These all are arrays, an array of integers to be more specific. Let's say we have a variable called M for matrix, which is, we will come to this part later, but which is an array of A, B, and C, but not the string A, B, and C. The array A, the array B, and the array C. So since we write here, when we're coming up with the type, we write here the type of its elements. What is the element type here? Here, for example, for this example, A is an array of integers because each of the elements is what? It's an integer. So you write integer into here. But here in this example, A is an array of integer, B is an array of integer, and C is an array of integer. So each of the elements has the type array of integer. So you need to paste this expression into here, which makes M an array of integers. Okay, array of integers. But why we represent 2D arrays like so? And the reason is, it is really straightforward if you, let's say, want to get the first column and the first row. Like it's very straightforward if you want to reach each of the cells. Let's say this is represented by 0 and 0, right? In mathematics, or 1 to 1. I cannot remember. If it's 0 based mathematics, this is 0.0, which is the 0th row and 0th column, right? 0th row, which is this part, and that and of that 0th column. Cool. Or if you want to reach here, this is 2 by 2, right? 2 to 2, which is the second row, 0th row, first row, and second row, and the second column, which is 9. Cool. But if we use this M, we can do this. M0, what does this return? A, right? This means M0, M index 0 means the array A, because we designed it like so. And if you, so since this is A, if we want to reach to the 0th index of A, what we can do is we can write this. M0 is A and A0 is 1. So M1, 2, let's say. What is this value? M1 is B, it is the row, and then the second index is the second column or second cell, okay, of this row, which is 6. So you can use this notation to traverse, to visit all of the cells of a matrix, of a 2D matrix. Okay, this is what I wanted to show you in the first place before jumping to the solution to the problems. This is how you can represent 2D matrices, in Kotlin or in different programming languages. You use array of arrays or list of lists. Okay, cool. Since we have this in place, let's go check out what is the problem again. So we need to calculate the diagonal difference. Let me copy and paste this here, and let me move all this code into a main function so that I can use this. I can use this matrix M to calculate the diagonal difference, and maybe I can print the diagonal difference. Okay, cool. So we need to calculate two things. The first thing is the sum of diagonal 1, or sum of left to right diagonal, or you can call it for short diagonal 1, which is 0 at this time, but we will start calculating it in a for loop. Let's say, like, ignore this diagonal 2 for a second. Okay, let's say we only want to calculate the diagonal 1, which is 1, 5, and 9 for this given array, but we also want to calculate any of the matrices, any of 3 by 3 matrices, let's say, which is given to us. How can we do that? Like, we need to get what to calculate diagonal 1. You need to get the cell 0, 0, and you need to also get the cell 1, 1, and you need to get the cell 2, 2, right? So that we get all of the cells in the diagonal, in the left to right diagonal. So usually, normally you can do that for all of the 3 by 3 matrices. But there is one gimmick. You don't know the size of the matrix. It can be 3 by 3, it can be 5 by 5, it can be anything, okay? You don't know. Because here it is 3, but ideally n can be a very big number. So they can feed you with a 10 by 10 array or matrix. So how can you then come up with this kind of solution? You don't know the exact numbers you need to use in here. For that, you can use a for loop, of course, because if you have a repetitive operation, if you need to do something repeatedly, then you can think of for loops, right? Or other loops as well. Let's start a for loop. And in this for loop, we need to start from 0 and go until n. But what is n? N is the size of this matrix. How can we get n from ARR? Let's say you define a variable n for sake of clarity and being explicit. You can use ARR dot size, or you can also use ARR 0th index dot size. The reason is these two are equal because you know that your array is a square matrix. So the size of the rows, the count of the rows is equal to the count of columns. Cool. So this is n. So you want to go to, you need to start from 0 and go until n minus 1. And there is a shorter representation of this, and that is to use until, okay? 0 until n. And since you have 0 until n, this means I will become 0, 1, 2, dot, 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 and it will go until n minus 1, n minus 1, okay? So 0, 1, 2, 2, n minus 1. You need to calculate this sum, right? To do that, you can do the same thing, but in a different way. Plus equals ARR I and I. Okay, what does this mean? This means now, since I will start from 0 and go until n, then we will add each of these expressions 0, 0, 1, 1, 2, 2, 3, 3, and until n minus 1, n minus 1. We will add all of these numbers in an array or in a matrix because we don't know how far it'll go. Maybe it's a 10 by 10 matrix. We don't know. We know it when we get the array in the runtime. Okay. So this is how you can calculate the first diagonal. Okay, this is cool. Let's run this by returning the diagonal 1. So instead of returning the diagonal difference, it'll just return the first diagonal, which should be 1 plus 5 plus 9. Let's see if it is. Yeah, So it returned 15, which is 9 plus 1 is 10, 10 plus 5 is 15. So yeah, which is correct. Like 15 is the number we were expecting. Now, the diagonal 2. How can we calculate diagonal 2? To come up with a formula or to come up with an algorithm, let's try to understand the positions of the cells we try to add into. Okay? Uh, let me write here. The first number we need is M2 0, right? No, sorry. It's 0 2. It's the zeroth row and second column, which is 3. So we need to calculate the sum of M02, M11, and lastly M20, right? 0 2 1 1 and 2 0. And if it was a 3 by, not instead of a 3 by 3, if it was a 4 by 4 matrix, it'll start from 0 3, and then it'll become 1 2, and then it'll become 2 1, and then it'll become 0 3 0. So let's try to understand a relation between these numbers. For that, I'm gonna list those numbers side by side and try to see, okay, this is starting from 0 and going until n, and this is starting from n and going until 0. That means for the row index, we can use I as we did here. So diagonal 2 is I and something, okay, something here, because this is I, because I is starting from 0 and going up until n. And yeah, the first index seems to be like so. But what about the other? Can you come up with a formula where you use I? So I is 0 here, I is 1 here, I is 2 here, and I is, let's say, 3 here. And you can see that when I is 0, this part is 0. When I is 1, this part is 1. When I is 2, this part is 2. So we can see that, okay, this is equal to I. You can understand that part. But how about this part? If it is I plus 3, then it doesn't work, right? I plus 3 is 3 here and 4 here and 5 here and 6 here. But instead of something increasing, we need something decreasing. How about minus I? Because when I grows, minus I shrinks or decreases. So if we say minus I, then it will be 0, minus 1, minus 2, minus 3. We got something decreasing, but this is not equal to what we have here. So I think you need to add something to minus I, or you need to subtract I from some value. For example, let's say 3. If it's 3 minus I, then it'll be 3 here. It'll be 3 plus, it'll be 3 minus 1, which is 2, and 3 minus 2, which is 1, and 3 minus 3, which is 0. Okay? So, yeah, we found the relationship. It is 3 minus I. But is it so? We use 3, but how about 2 by 2 matrix, which goes like this? Again, this part is I, but this time instead of 3, we need to use 2. Interesting, because now we use 2. This is the last index, right? This is the last index. I think you are already guessing it, but we need to use n minus 1 minus I, because this is what n is here 3, and we use 2 minus I. When n is 4, then we use 3 minus I. So the formula for this is n minus 1 minus I. So you need to write here n minus 1 minus I, or n minus I minus 1, which one you fancy. Got it? I'm gonna delete those. And since I have the first diagonal and the second diagonal, let's get the absolute value of both of them using ABS, which means absolute value, from Kotlin math package. Okay, now we have calculated the diagonal difference between the first diagonal and the second diagonal of a matrix. And let's see if our code works in our example. It says it's 0, but is it so? The first diagonal is 15, cool, and the second diagonal is also 15, cool. Then yeah, the difference is 0. But let's change this and make this, let's say, 9. Then the difference should be 6, right? Let's run this and see if it's 6. Yes, it says 6 here, because now this is 15, but this is 21. That is the reason we have the difference 6. So our algorithm seems to be working, and let's upload this to HackerRank to see if this really works. We got a compilation error because we haven't imported the ABS function. To do that, you can get this import and use this import here. And now submitting the code should pass all of the test cases. Let's see. Cool. That is how you pass the diagonal difference problem. This is enough for this video. It's already been very long. See you in the next episode. Take care.